Right, a bit of a continuation from my previous video. I was talking about the exit coil, which is basically the coil which is energized and expels repulses the rotor as it's leaving the generator coil. Yeah, so I've had some really good results with it, but not optimum. So obviously the coils that I'm using were not designed to be used as an exit coil. They were primarily designed for the generator. I'll just recap those. Hang on. Sorry, I've got the big light on right now. But let's see. So my coils that I was working on before, I mean, there's nothing wrong with them. I just wasn't getting enough juice out of them for the generator part. Um, so what I did was I used a single coil, just a single coil, and I put it on the end of my round coil, which is under my concentrics. Uh, so basically the round coil is the one that's generating the power, and the coil that's under there and on the other side, I've got super glue in the way, sorry about that. These coils at the rectangular coils on the end are the ones doing the ejection of the rotor. Well, so I'll explain a bit about it. So I've got this capacitor on there. Originally I put two capacitors, one on each coil, and I realised because the coils are actually in series with the rest of the coils, I could just put one capacitor across the coils because they're actually it's like they're basically like center tapped at that point. They're basically connected in series anyway, so just one capacitor is enough. So I was working on a strategy to adjust the delay of the pulses. A little circuit diagram here. I've actually only drawn one coil on there, but you can just imagine that one coil is two coils because it's the same thing, same principle. So what was happening was when you first power the device up, it's outputting into the supercapacitors. It's generating somewhere. It's around 297 to no, sorry, 197 to 220 something milliamps into the supercapacitors that are to around 4.7 volts, around 5 volts, because they usually don't get discharged below that because of the circuit that the boost converter that drains them down doesn't conduct below that point, so they usually end up at that voltage when I first started up. So what I saw was that the waveform, the activation of the exit coil, as I call it, didn't really start to kick in until I got to around about 5,000, 4,500 RPM, 5,000 RPM as a ballpark. It's pretty much on that nose actually. But at about 5,000, it started to make a difference. I started to see a small pulse train on the waveform and on the edge and the exit part of the wave as it drops. and it was at that point that I started to see an increase in RPM, and also the amount of current required to keep maintaining the drive, the motor, which is that thing to drive everything. The amount of power required to maintain and keep running that was also dropping off slowly as it was charging the supercapacitors up. So the exit coil made a difference, because when I took the capacitor off it, that meant that the exit coil was getting energized immediately instead of delayed, because the capacitor has to charge up before the exit coil can actually switch on. So and when I took the capacitor off, I saw more drag, and well, it wasn't more drag, it was just the drag that would have been there had the coil not even been in place anyway. So anyway, so what I did was so what I've been working on is two ways: a variable resistor in series, something like a 10 ohm, but you can't really get many variable resistors that low anyway, so I'll probably just use some discrete resistors and find the best value or something like that, because we need to be pretty low value to get the current to go through there, otherwise I end up with losses. And then I was thinking, well, actually we could use an inductor in series, because then it would create a slight delay to the capacitor and to the exit coil. And then I thought, hang on a minute, why don't I just rewind the actual exit coil? Because at the moment the exit coil is one of the previously wound coils that was designed for generating power, and it was quite a low impedance. It's about 4 ohms, and that is pretty low. So it's not going to do a lot of work, because you have to have quite a large amount of current flowing through it to make it work, to do anything useful really. So what I'm decided to do was to wind another coil on my coil winder, which is what I'm in the middle of doing. So instead of 32 SWG wire, I'm using 36. I think it's 36. Look at my bobbin. Yeah, I think it's, yeah, I keep forgetting stuff. Yeah, it's 36. So I'm winding, instead of 4 rows of wire, instead of having 4 complete rows of wire, I'm not counting the turns, I'm not bothered about the turns, I'm just interested in how much wire is on there. So instead of 4 rows of the 32, this will have 6 rows of the 36, because it's thinner wire, I can get more on. And because it's going to be a higher impedance, a higher resistance on the coil, it will also be more energetic in doing the work that I want it to do. So I'm going to sacrifice a small amount of my power that's generated. That's fine, because my generator coil is able to produce over 60 volts peak to peak. I've had it up, actually I've had it up to 70 at one point. But yeah, it can produce about 60 volts peak to peak, and and I can draw about 200 milliamps, over 200 milliamps, just for that one set there. So I'm thinking, well, why not sacrifice a little bit of that power to send it back through this pulse coil? Because it's a higher impedance, it means that the current is in series with the coil. It means I'm going to lose a small amount of current and a small amount of energy, but not too much, because I could probably put a larger capacitor across there. So it's going to, during the time that it charges that capacitor up, that's going to be the output that's going through it in series. And once that's charged, and basically the output stops, the generator stops producing energy, the capacitor will remain charged for a fraction of a few milliseconds, long enough to power the exit coil, which will sustain a pulse to exit the rotor, and hence less drag. So that's what I'm working on at the moment. I thought, well, I'll do that first, because it's a lot easier, it's simpler to wind a couple of bobbins with more wire on. It's not a big job really, and I can just swap them over and do that. and try that and see what the difference, if it's an improvement. It should be an improvement, but I expect to lose a little bit of output power anyway, but I'm not worried about that, because you see, the advantage of having a higher impedance coil means if I want to shunt power through, if I don't want to lose as much power, I can simply put a 10 ohm variable resistor across this coil, so I can attenuate it that way as well. So I'll be able to bypass some of the current straight through to the, the output section. So yeah, I could have a bypass variable resistor on there if I wanted to attenuate it that way. But then that would discharge a capacitor as well. So yeah, there's always a catch. So yeah, but there's ways around it anyway. But during the high amount of current demand, you know, it's about 200 milliamps of current going through there. I mean, it's not going to it's going to charge that capacitor up anyway. So yeah, or I could make a capacitor bridge. Basically, it's like a low pass filter circuit. Or it creates a delay. If you've got a if you've got a let's see, you've got a resistor, capacitor, another resistor, capacitor. That's a ground. Then you basically create a delay circuit, because what happens is you get power coming in through a resistor. This capacitor has to charge up, and as this rise time of this capacitor, as it charges, the power will go through the next resistor and charge up another capacitor, and you're creating delays, because there'll be basically that will charge first, and that will probably be something like a tiny little dot like that, and as that's fully charged, and if the power is removed from the input, which is this end, that will continue to discharge into this capacitor, and we end up with a big wave there, and this one will start to go down, so it'll be about half as much, really, about something like that. So yeah, that's one way of creating a delay circuit, but that is a bit overkill, because I'm only wanting microseconds. I don't want that much of a delay. I mean, I was thinking about it earlier, and I thought, well, it's ridiculous. These resistors would probably be chokes, really, like something like 0.1 of an ohm, 0.2 of an ohm. So yeah, forget about that. That's why I was thinking about the choke. You know, having a choke there, because a choke is an inductor, and you have to you basically charge up the flux on the ferrite, which is much faster acting. It's much faster acting, and it works the opposite way to a capacitor. Instead of having an instantaneous pulse going through, you have a fraction of a delay. So having a small choke even would work. Quite a low impedance choke as well. So that's another option. So yeah. Anyway, that's really all I wanted to mention about this. Sorry about the camera wobbling, it's me, I've got a shaky hand. Yeah, so there's not much. Why have I got this green blob on here? Have I muted myself? I hope not. Yeah, the speaker thingy magic's gone green. I don't know why it's not doing that. Anyway, so right, so an inductor is also possible, because I can have a tunable core, which is basically something like that, symbolizing like a tunable core to attenuate my I could use a transformer. I've got some tunable transformers kicking about, old radio ones. They would probably work for this anyway. It's nothing fancy. It's basically just creating a small delay of a few microseconds. That's all we really want. I can tune it more effectively. So a tunable choke, a tunable inductor is probably the best way of attenuating the coil, as far as I can see, because I won't lose as much juice as I would do if I had a resistor array. So anyway, yeah, I'm doing a lot of from memory, really, from years ago when I was practicing with radio stuff and all that. Yeah, variable resistors. I thought about them and I've dismissed them because there's too many losses in them. I mean, you just burn up heat. You're just creating heat in those resistors and you're just wasting energy. And an inductor is more efficient. You use less energy. You lose less energy. Anyway, I hope you enjoyed the update. That's it for now.